Good morning, everyone, and thank you for joining in for the F5E Lunch and Learn. Please allow us 5 minutes for more attendees to join in. Thank you. Hello, good morning, everyone, and thank you again for joining in for the F5 Big IP SSL Orchestrator, e-launch and learn with exclusive networks. Today's session is going to be an interactive, very interactive session. I have unmuted all. So in case you all want to have a word or speak to Serge, we can allow that to happen. Yeah, everyone has been unmuted. So please, if you all have anything to say or if you all want to stop and ask Serge a question during the presentation, we can do that. Serge is our technical solution manager at Exclusive Networks, and with him assisting is Mohammed Kaub, the solutions engineer at F5 Networks. And over to you, Serge. Let us start the session.
Thank you, Ryan, for the introduction. Thank you, everyone, for joining our SSL Orchestrator Technical Bootcamp or workshop session today. Honestly, it's for you to know, it's not a webinar. Actually, we are using the GoToWebinar platform, but this session is an interactive session. The way that we used to do it as a physical bootcamp, we are trying to have the same experience, unfortunately, remotely. Of course, we would have. Ryan, you are muting me.
So sorry.
Okay. So yeah, actually, we wanted to do this bootcamp the way that we used to do in a room all together, having more interaction. But that's the case now with the pandemic. Physical events are not yet allowed. So today our session will be on the Big IP SSL Orchestrator. I'll be presenting. My name is Serge Ghanem. I'm Technical Solutions Manager at Exclusive Networks, handling the pre-sales, cross-selling and upselling strategy for all cybersecurity vendors in our portfolio, focusing like 80% of my time on F5. And I'll be with me, we're gonna have as well Mr. Mohammed Kawouk, my colleague and friend from F5 Networks. He's solutions engineer there, and he has a lot of experience on the SSL orchestrated technology in general. Hi, Mohammed. During this session, we're gonna be going through the following. The following agenda. First of all, the challenges with the encryption, the overview on the SSL orchestration and orchestrator mainly in F5, and last, it's going to be the hands-on experience on the SSLO guided configuration and how easy it is to configure. Before that, I would love from you guys to hear from you guys your experience on the solution. Do you have any knowledge on this product? Please feel free to unmute yourself and speak about it. I would like to know if anyone has any experience on this specific solution in F5. Anyone would like to speak to give his personal experience? Have you heard about this solution before? Am I audible, guys? Am I audible, Ryan?
Yes, you're audible.
Okay. Okay, so it seems no one has an experience on this solution or positioning it. First of all, let's speak about the challenges that we face with encryption and why we are positioning SSL orchestrator. And why it's needed in every single environment, especially nowadays. So first of all, and by the way, guys, please, I think there is someone question. We cannot unmute ourselves. Ryan, they cannot still unmute themselves.
I'm not sure why the platform is not allowing it at the moment, but they can drop in their questions at any point of time.
Can I unmute them from my side? Can I unmute them from my side, Ryan?
No, it's not allowing us.
Okay. So please feel free to put your questions. So far for now, on the questions area, and we'll be able, we hope we'll be able to answer you all the questions. Okay, so let's start. First of all, the need of having the SSL orchestrator nowadays, the encryption, the encrypted traffic is increasing rapidly. So in 2016, you can notice that 40% to 50% of all the traffic was encrypted with SSL. However, according to a net market share, net market share of data in October 2019, the proportion of encrypted web traffic is more than 90%, and it's increasing drastically. We can see from this chart as well. It displays a recent historical trend in the percentage of websites using HTTPS as a default protocol from 2017, October 2017, till July of 2020. And if we draw the trend line here, if we draw the trend line, you can notice that in October or in mid 2021, actually the slide is a bit old, but it is the situation now. 70% of the websites are using HTTPS as their default protocol. 70%, which means if we draw the trend line, the trend line more, by end of 2022, almost all the websites will be using 100%, will be using the SSL or HTTPS as a default protocol by 2022. So what's causing the increase in the encrypted traffic? Who can tell me? Unfortunately, I wanted to know from you guys. Okay, Sanish, thank you for your input. Yeah, a lot of people, a lot of pre-sales guys from our partners having the theoretical knowledge on this product. And that's why this is the main purpose of having the hands-on experience during our technical bootcamp, to start to understand more this product and be able to position it in the customer environment and speak about it more for our customer and try to have some technical experience on this product and hands-on. And this is what we're going to be doing today. Okay, so yes, actually, Sanish is answering, and Mudresh is answering the question: what is causing the increase in encrypted traffic? All are adopting secure communication over clear text, confidentiality, and integrity. Yes, these are the main point. But if we go through the top 6 major SSL growth drivers. First of all, the adoption of HTTP version 2, the web application privacy, the information privacy, the growth in social media and social network website, the regulatory compliance, DSS, GDPR, and so on. The ease of adding encryption nowadays. It's very easy to add encryption nowadays. And the adoption of web-based applications such as, for example, Office 365, Concur, a lot of corporate applications or software as a service application that needs to be using encrypted traffic. So, of course, confidentiality and integrity moderation is one of these points as well. So, and because one of the goal is of SSL is to encrypt the data, cyber criminals are using as well SSL encryption to hide their malicious activity. Like SSL allows cyber criminals to evade detection. So you can know nowadays a lot of cyber criminals are injecting in the encrypted traffic some malware, some malicious traffic, and this malicious traffic is not being able to be inspected by the security devices due to the lack of visibility or the lack of decrypting the traffic in order to see what inside it and to do, for example, the SSL decryption, which is needed on different layer of OSI from layer 5, layer 6, and layer 7, which is the application layer. So as well, here an example of a traditional setup for security devices, which is called daisy chaining. And this daisy chaining is nowadays has a big impact and problem in the customer environment. So first of all, the organization, let's take an example. There is an organization that has several security devices, including web proxy, IDS, DLP, ICAP, IPS, next generation firewall. And in this typical architecture, the internal client, for example, is requesting the internal client is requesting traffic to the internet. So what's going to happen? So it begins the process of going through the devices. In this case, it starts with the web proxy, for example. This device must decrypt the traffic, then inspect, then re-encrypt. And so in order to inspect the request, of course, so it will re-encrypt before sending it along. This is time consuming, and it will cause more latency and additional devices added to chain, and it's going to take a lot of time. And because if each device is independent, each determines if it will or will not decrypt. So some may not.
Search, just 1 minute. I think some of the guys are having an issue with the audio.
Guys, can you hear us, please? If you can. Am I audible, guys? Ryan, am I audible to you?
Yeah.
If I'm audible to you, I think I should be audible to everyone. I think from Suresh side.
Yeah, that's fine.
So can you hear me again?
Yeah.
Okay, thank you, Sanish. So, so as I mentioned here, it's a lot of time consuming, a lot of decryption and re-encryption on each and every device. And in that case, whenever we are decrypting and re-encrypting, some of the devices can decrypt and re-encrypt, some of the devices that cannot have the decryption part, for example, some of the sandboxing solutions. So in that case, let's go back to the presentation. Not all security devices have visibility into the SSL traffic. So As well, there are two key challenges with the daisy chain network design. First, this opens up multiple points of failure along the daisy chain of device. If any of the device is offline, it could affect the entire traffic flow. Second, because of the high CPU requirement for the SSL encryption and decryption, especially when we are using different types of keys nowadays, 1K to 2K to 4K, and this is drastically impacting the performance, capacity, and usage of the devices. And in that case, it's impacting the performance of the user request, and it can cause delays and so on. By the way, Ryan, please, if there is questions, please keep an eye on the questions and ask me directly if you can. Okay, because I cannot
Sure,
keep
noted.
open.
Yeah.
Questioning box, the question box.
Yeah.
And here, by the way, some quotes from some customers, okay, stating, so for example, this customer, our FireEye has gone from effective to irrelevant because of the blindness to the SSL traffic. We have another customer, we have significant challenges with the growth and encrypted connection we are seeing lately. And another one, we filled over 12 different security services and we struggle with using all of them effectively. So organizations need help with the challenges of SSL encryption while also utilizing their security devices. And you can notice, guys, from the pre-sales perspective nowadays, whenever we are sizing not only F5 solution, whenever we are sizing other solutions, for example, in the daisy chaining, always for the firewalls, for example, we oversize. Why? Because 80% of the performance degradation on the firewall will be because of the SSL decryption. Same for the web gateways and so on. So imagine how much we can reduce the cost if on the customer and allocate more budget in order how much we can allocate more budget with the customer, help them allocate more budget for different security solutions when we are doing an SSL decryption before sending the traffic or steering the traffic to their security solution. So it's gonna be less cost. These devices, the firewall, the IDS, the DLP solution, the web gateway will not be needed to be or will not need to do the SSL decryption and oversize them. So instead, for example, on a big model, positioning a big model of a firewall, we can, let's say, go 20% more down, let's propose a smaller firewall model. And in that case, the customer will have more budget to have different solutions when we are proposing the SSL orchestrator. And we're gonna see how it helps. So any question now? Okay, so far. So let's start with the overview on SSL orchestrator and how it helps in addressing all these challenges that we have seen. So first, as a review, I will say without a solution, the organization will have no or little SSL visibility in their traffic flow, especially when we are speaking about daisy chaining. So with F5 SSL orchestrator, it is the solution to all the challenges we have seen so far in the previous slides. So the SSL orchestrator with both inbound and outbound traffic. But these, and we're gonna see some example that will focus on the request. So when a request arrives to the SSL orchestrator, it can be first classified. It can be first classified by several categories, such as source IP address, destination IP, IP geolocation, domain name, protocol, like all these classifications. So based on the determined classification, SSLO, and by the way, SSL orchestrator in F5, we refer it to SSLO. This is the abbreviation. SSLO can make several decisions. So one decision it can make is whether not to decrypt or whether not to decrypt or to take the action to decrypt. So first action, for example, here, if the action match is set to bypass, for example, SSLO will not decrypt the request. However, if the action is set to intercept, the SSLO will decrypt the request. So at this point, SSLO can send this decrypted request to other security devices. When the traffic is being decrypted or not decrypted, SSLO can steer or send the traffic to other security devices. And in that case, it will break the what's called daisy chain. So if the request was decrypted, SSLO now can re-encrypt the request and forward it to the internet or to the destination. So first of all, let's see what are the devices that can be supported by the SSL orchestrator, or what are the devices where the SSLO can steer the traffic to. There are several types of security devices that the SSLO supports. It supports the inline HTTP web proxies, the inline layer 3 proxies, or what's called outbound inline layer 3 proxies, inline layer 3 devices like next generation firewall, inline layer 2 devices, DLP or ICAP solutions, tab security devices, and so on. In this example, we have configured the devices like Blue Code as a secure web gateway or web proxy, the Symantec DLP, Cisco IDS, and a Palo Alto next generation firewall. Okay, so these are an example of a device that can be supported. It's not limited to these brands. It can have a lot of brands, or even its generic layer 3 device, inline device, layer 2 device, and so on. I think there is a question. Sumit, can you hear us again now? Ryan, can you check with Sumit if he can hear us? Ryan? Am I audible, guys? Kauk, am I audible?
Yes, sir, Shikha here. Yes, you are audible.
Okay, thank you, Shikha. What could be the difference between the F5 SSLO and other appliances doing the same function? Okay. Just 1 second.
Yes, I can hear you. I wasn't able to unmute myself, Serge.
Okay. Yeah, so, okay, thanks, Ko. So what could be the difference between the F5 SSLO and other appliances doing the same function? We're gonna be seeing that, we're gonna see that, Muhammad. Thanks for the question. But mainly, one of the advantages of the F5 SSLO, it can do all kind of topologies, and one main part of it is the layer 3 outbound and inbound topology, where other SSL orchestrators, or mainly they are called themselves packet brokers, they can do only the layer 2 decryption and re-encryption. So as F5, as a full proxy solution, since F5 is a full proxy solution, it can handle that part. Plus, the advantage of F5, it can do all the basic functionality that used to be part of other modules like LTM, which is the load balancing, monitoring all the solutions, the security devices, to see if they are active or not in the service chain. We're gonna see that as well. Plus monitor the health of each one of the security device to see if we send to this device, to this security device, or to this security device or not. There is a lot of advantages. These are, I stated.
Serge, yeah, if you allow me, I want to add just one point
please,
here.
go.
Because guys, I come from like a semantic background, and I have done some a lot of SSL in my last 3 years. So one of the main advantages of F5 SSLO, as Serge said, is the layer 3 topologies. So just a quick comparison with the other products. So the main purpose of the other products comes from targeting layer 2 only. So think of semantic SSL as an example. It's a good technology. It does a great job. When it comes to L2, they do only their proxy. So they do only the semantic proxy. They cannot really integrate with other proxies or next-gen firewalls. So anything that has a NAT in place, anything that changes the packets, they cannot handle from that perspective. So the use case can expand with the F5 technology to all kinds of devices, anything that needs SSL decryption. So this is mainly the statement that I want to highlight here.
Thank you, Ko. And we're gonna see that, by the way, during our presentation, Juma. Okay.
Exactly. Thank you.
Okay. So first of all, this is, by the way, the way of even configuring the SSLO. We're gonna see later on during the hands-on presentation how to configure the SSLO. So these are the sequence of, and from in these slides we're gonna be the see the sequence of the configuration of the SSLO. So first of all, we're gonna list the devices that gonna be part of the SSLO traffic steering. Okay. Then we need to configure what's called the service chain. So once we have established the devices, we then define the service chain. A service chain is a collection of different security devices in a specific order. So, for example, we can create a service chain named, for example, all services. Okay. This is which will be for all 4 security devices. For example, in our case, for the web gateway, the DLP, ICAP, IDS, and next generation firewall. Okay, and we can create a second service chain name, for example, IDS and next generation firewall, containing just these 2 devices. And we can create, for example, another service chain which only have in it the next generation firewall. And we can now use all these service chain in different SSLO traffic flow. But how the traffic flow will be happening? Okay, how? With the security policies. So these security policies will contain the service chain. So once we have established first the devices, then we have established the service chain, we can now configure our security policies, which will allow us to, or allow the orchestrator to send the flow accordingly, or create the flow accordingly. So a security policy contains the rule that controls how traffic is processed through the SSL orchestrator. And here is, for example, a client that is making a request. Okay, so as we mentioned first, we need to classify his request. So let's say his IP reputation, the IP reputation, his source IP, where he's sending the traffic, to which URL, category, the protocol, and so on. Once determined, we determined as a classification, we can then, let's say, steer the traffic to what's called security policy. So, or decide to which security policy we want to send the traffic. So, so for example, in this security policy, we decide if the SSLO should decrypt or not. So these let's say we want on this request, if he's sending to a specific geolocation or destination, we want to intercept. So first of all, we intercept, and then we want to send the traffic to the service chain. Remember, we have configured 3 service chain. One of them is the IDS and the IDS and next generation firewall. So we intercept, we have done the SSL decryption, then we send to the IDS and next generation firewall, then we re-encrypt and then traffic to the destination of this user, the destination that the user is requesting. So for another one, the next classification will be, for example, for all HTTP requests going to a financial URL category. Okay, so you are a financial, of course, using HTTPS. What we're going to be doing, these requests are only needed to go, for example, we decide to take them only to the next generation firewall. So we don't want the SSL orchestrator to intercept or to do the SSL decryption. We just want to do the bypass. We send the traffic to a service chain which only contains the next generation firewall. Okay, and we can send directly straight to the internet. Okay, another security policy based on the classification is to intercept all the traffic coming from the internal IP subnet. So these requests should be, if they are not classified as a specific destination or IP geolocation, or they are not classified as a financial website or destination, all other traffic should be sent to all services. So it will pass through all the services. By the way, when we speak services, this terminology on F5, services means the cybersecurity devices that are listed in the SSL orchestrator. They are defined as services. So this classification will send all the requests, will intercept and send the request to all services, re-encrypt and send it to the internet. So this is how it will happen when it comes to the traffic flow for IP geolocation, for the traffic flow for IP geolocation match. So let's take an example for that. For this first classification rule, an internal client request arrive at the SSL orchestrator. So the client may be in the internal IP subnet, but this rule are being matched in order they are listed. So let's say this rule has as well all the IP internal subnet, and however this user is coming from internal IP subnet. Okay, if this rule is listed before that, okay, it will take precedence and will be matched first. Okay, so the SSLO classified the request and identified that they are requesting a URL that is hosted on a server inside a specific IP geolocation, and therefore they may it will match this first rule. It will intercept, of course, decrypt, inspected by the IDS and the next generation firewall, and be sent. Okay. Another one for the financial website as well. It will be sent to the SSLO. It will not decrypt it. It will bypass, send it to the next generation firewall, and then to the internet. The traffic flow for the internal subnet will be passing through all the. The next part is the dynamic scaling, and this is one of the key advantages of the SSL orchestrator, its ability to dynamic scale. So because the SSL orchestrator runs on the big IP system, as I mentioned previously when Muhammad Jama asked me this question, it can have the advantages of the LTM. So for example, each of the security devices is actually configured as a pool on the big IP system. And because of that, we can include multiple devices and multiple pool members. So we can do the load balancing here. If we have, for example, 3 web gateways, we can do the load balancing between them. So SSLO can use the multiple pool members for load balancing. SSLO can monitor the devices and identify if the device is down and take it out of the pool. And the SSLO can even identify how each device is performing and send more requests to the devices that are underutilized. Okay, you can see here, for example. And as well, SSO can also completely bypass an entire service, you can see that, if the service or the device has failed. And we can either add a new device pool member or bring this device back online, and it will automatically be added back to the SSLO traffic flow. Is it clear, guys? Any question, please feel free to ask me at any time. Ryan, are you still with us, Ryan?
I'm here, Shikha instead of Ryan.
Yeah. Shikha, can you check if we can unmute the team or the attendees? Is there?
Okay, let me check.
So Muhammad Juma is asking regarding integration with other F5 technology as LTM, GTM, ASM, will add pros or cons? Of course, will add pros. Since now, previously, when the SSL orchestrator was first released, it was a purpose-built solution. So it was only sitting on one single device. At that time, it was called Herculon. But nowadays, the SSLO can be a license installed on top of an existing F5 unit, which has LTM or ASM or now AWAF. There is no more ASM or GTM running on top of. And this is one of the advantages of having the SSLO license installed on top of them. And plus, we're gonna see one of the topologies with the SSLO where the device is already running LTM, and this SSLO feature or license is installed on top of it, and how it will help as well the inspection with the WAF and with the load balancer, and how it can steer the traffic as well. So it can use in different topologies at the same time. Okay, inbound, outbound layer 3, inbound, outbound layer 2, published services. We're gonna see all these kind of topologies where the SSLO can be installed. And what about integration with F5 Big IQ? For now, the SSLO is not part of the Big IQ management, so we cannot manage the SSLO module on the F5 units from the Big IQ for now. Maybe Muhammad Kawouk can tell us if it's going to be in the roadmap or not. Kawouk? Okay, I'll unmute you.
Yeah, when I try to unmute myself, it doesn't work. Yeah, so two things here. When it comes to WAF and SSLO, we are working with several customers today to add the WAF in the SSO decrypted channels. So you can have your IPS, you can have your proxy, you can also have your WAF for the inbound traffic. So we can decrypt and send it to the WAF. This is one of the things. The other service that we have launched actually with the latest releases is WAF as a service on SSLO. Yes. So technically, you can get the SSLO itself, and you can have a kind of WAF service. This is kind of internal ICAP between the SSLO and WAF. So you can just simply click and configure that. and get this service to be deployed. And this works perfectly, in my opinion, to customers with a small number of applications, because the difference between both is that the WAF as a service, you have limited number of WAF policies, while if you want to have a full WAF, you can just have SSLO, decrypt, send it to the WAF, and you can apply all the policies you have on the WAF. I will send you a link for the WAF as a service after that to see and read about it, and maybe we can see how this can, myself and Serge can help out positioning the solution and who are the targeted customers for this one as well, because this can be a very good added value.
And
And
there
in
is
the
one
roadmap of
question
SSL is rich.
yeah.
Yeah, go ahead.
There is a question, Muhammad, for the big IQ. What about the integration with big IQ? Is it in the roadmap of managing the SSLO from the big IQ?
It is already integrated with the latest version, so you can do that with big IQ. However, we recommend not to get there right now. So big IQ has been through a lot of changes. So here we're talking about like deep technical and like full transparency. We have done a lot on big IQ. So the transition from 6.0 to 7.0 was a big transition to fix lots of bugs that was on the big IQ. So now we are in a better state. When it comes to WAF, I'm very confident with the big IQ. However, when it comes to SSLO, I prefer to keep it on its own for the time being. We can use it big IQ maybe for taking backups, taking like config backups and all these things, but I don't recommend to fully manage it from the big IQ for the time being.
Okay, thanks, Muhammad. So in the topology where SSLO will be fit in the perimeter, replacing the firewall or DM. Okay, so actually it depends on the topology that we're gonna be using. So if we are using, of course, the SSLO as a outbound or proxy topology, we're gonna see that explicit proxy or outbound. For the explicit proxy, just we not need to change the proxy in our browsers to be pointing to the SSLO IP address. However, when it comes to the full traffic passing through the SSLO for the outbound, of course, it will be the default gateway, or even we can keep the default gateway as it is, for example, a router of a firewall, and we can ask this router to reroute the traffic, all the traffic, to the SSLO. So it will be the gateway of the router. And of course, it can be for the DMZ, internal, or another question: can I have SSLO decrypt my hosted website traffic, then feed the local ASM or AWAS as well as some third-party WAF, for example, in Perva? Of course, we're gonna see that in the topology as well. If you can just wait, Sanish, for the next slides, we're gonna see all the topologies and how we can install the SSLO in the inbound traffic to feeds the ASM or to the SSL traffic before sending it to the LTM, ASM, or any F5 device. Hello, Serge. And we know what is the big advantage over semantic SSLO when discussing that with customer, which feeds are in F5 and not in semantic solution. This is, I think, Kawuk needs to answer that since his background and he's coming from semantic. Kawuk, for you, please.
Yeah, well, what's the question again? Sorry.
The key differentiator, yeah, the key differentiator between the F5 SSLO and semantic SSL decryptor.
Yeah, the key differentiator is layer 3 devices. This is one of the things here. So layer 3 devices, especially next-gen firewalls and proxy, semantic has a lot of challenges when it comes to decrypting for any device that does NAT. So the only supported device with the semantic SSL is the semantic proxy, because they have created an integration between both devices. If you have a force point device like proxy, if you have Palo Alto that does NAT, because they can do Palo Alto IPS, Palo Alto layer 2 only, they have a lot of challenges, and most of the time it doesn't work. So however, with F5, it doesn't matter what is the solution, what is the product, we will be able to do it. However, as much as you complicate the deployment, as much as it gets complicated. So here comes the use case of the customer and how to implement the solution and how we can simplify the architecture to implement it properly in the customer's environment. But these are the main differentiator layer 3 devices. We can send like after this call to the whole team. I'm taking notes actually on the WAF integration with SSLO, WAF as a service, also the competitive information with the semantic and the benefits of our solution compared to the semantic solution. We'll send after this call all these notes. So for your reference, guys, to see all these details, and we can have maybe brief chat about every single one at a later stage, if this makes sense.
Kyoko. So any other question, guys, before continuing? So we have seen first, what are the services or devices that can be supported in the SSL orchestrator and their type. Then we have seen the service chaining. Then we have seen the security policies. Of course, before all of that, the classification, how we can classify the traffic. And we have seen the dynamic scaling in the SSLO when it comes to the if the service is down, the load balancing, the if there is any service to be bypassed or failed, and how it can be automatically how can be automatically be out of the policy, and we can have it automatically up again when the service is working properly. So I think there is one more question.
There is a question from Mohammed Goma, and he's asking for in L3, is there VE?
Yes, and for inline layer 3, there is VE. For inline layer 2 and inline layer 2, there is no VE. It's only for the hardware. Does it support fail open in event or hardware software failure in layer 2 mode? No, it doesn't support fail open. We're gonna address this point and this challenge in the next slide, if you may allow me, moderator. Okay. If you can just wait for it a bit, how we can address this point when it comes to layer 2 failure, and how we can do the fail open. Okay, but in like a very fast answer, always whenever we are positioning SSL orchestrator, we position it in HA. So it's not a challenge for us. It's not a problem when we are having the HA part. So if we are working in HA, if there is a failure on the second device, automatically the second device will take over. And if the customer is going for a standalone, we can add another fail open kit, which is like very a small fail open kit next to the SSL orchestrator, which is gonna open the traffic for us and will redirect it directly to the gateway or to the next hop in the network. Okay. Okay. So we're gonna speak about that more when we reach the this point. Okay. Any other questions so far?
Yes, Serge, we've got a question from Madresh, and he's asking.
Yeah, I answered. Yeah, I answered that part.
I got it lately then. All right.
Thank you. Thank you. No problem. Okay, so let's continue with the session. I've seen the dynamic scaling. So, and the dynamic evolution, and this is very important whenever we are introducing the SSLO for any customer as well. So with the SSLO supports what's called dynamic evolution, which it means we can dynamically introduce and evaluate new services or new devices for POCs in service changes with test traffic before altering production design. So for example, we want to introduce a squid ICAP device, for example. So we can create first for it a service chain. For example, let's say we want to test it with the next generation firewall. So we add a new service chain containing the new squid device and any other device that we want to choose. We can simply add a new classification rule for one or more source IP addresses. For example, we can have one source IP address or two source IP address in our internal network. Okay. So SSL classify the request, identify its matches. The first rule, decrypt the request, send it to the new device along with the other device in the service chain, then re-encrypts it and forward to the traffic to the internet. So once we have tested the new device and we can add it to any of the existing service chain. So we can add, for example, this device, and this is how we tested first with the SSLO. So nowadays, for example, we can have a POC for any ICAP device, but we cannot know, or we cannot know during the POC if it will work with other solution. It will cause for us a single point of failure, for example, in a daisy chain. That's why we can test it with the dynamic evolution feature in the SSL orchestrator by creating service chain for it, classify it, and then add it later on to the services after testing it. And this is something very important. Of course, it will not cause any problem on the production traffic. So a lot of questions were coming for the SSL orchestrator topologies. For the SSL orchestrator topology, and we're going to speak for each one of them, okay, on each one of them. We have around 6 orchestrator topologies, SSL orchestrator topology. First of all, one is layer 3 explicit proxy, and this is where we can have the layers, the SSLO as a proxy solution that proxify the solution for us before sending it to the internet on the browser level, on the web traffic level. Then we can have the layer 3 outbound topology, and layer 3 inbound, layer 2 outbound, layer 2 inbound, and what's called existing application. And this address and this topology address the question of let me see who asked this question. Sanish. Existing application that is sitting on the F5 or sitting on a different LTM or WAF or whatever it is. So this topology addresses your questions. Okay. So you can notice in this slide there is 6 topologies in this slide. 2 of them are like in gray. Why? Because this screenshot is taken from a virtual edition F5 machine, VE, and with the VE, the layer 2 outbound and inbound topology is not supported. The layer 2 is only supported with the hardware device of F5. Okay, so let's start to speak about each one of these topologies. First, the layer 3 explicit proxy. So, which is the first topology. In this example, we're going to see that the client is an internal user who needs access to the internet. So when we create a layer 3 explicit proxy, the SSL orchestrator, we will end up with a big IP virtual server, of course, that has an IP address and port listening on the internal VLAN. Okay. So all client computers will need their web browser to configure to point to this explicit proxy. You can see that either we can do it manually or not. So for HTTP and HTTPS and even FTP. So these settings can be configured manually, as I mentioned, and can be configured automatically via the Active Directory, group policy, or proxy auto config scripts. So and it's important to know that every web browser proxy settings are configured differently. Okay. So now, whenever there is a client using a web browser and accessing an HTTP or HTTPS web application, the request will be forwarded to the SSLO proxy, okay, explicit proxy, which can then forward the request to the service path, then send it to the internet. So this client workstation are also configured with a default gateway, of course. In this case, this default gateway will not change to the SSL orchestrator. Only what's related to the HTTP, HTTPS, and maybe FTP traffic will be going through the SSL orchestrator. All the other traffic will be going to the default gateway and be sent to the destination. So if the client workstation is using a different protocol, in that case, such as, for example, remote desktop, all this traffic will be going through the default gateway, which will then forward to the remote host or to the destination. This is the layer 3 explicit proxy. Any question on the layer 3 explicit proxy topology, guys? Any question? Okay. I'll wait a few seconds if someone wants to put a question here in the chat or in the questions area. Now, let's go to the second topology, layer 3 transparent proxy, or what's called layer 3 outbound proxy. So the next SSL orchestrator topology is this one, which is the transparent proxy. Okay, it's referred as well as outbound in the guided configuration of F5. So the client, once again, is sending the traffic to the internet. He wants to access the internet. In this topology, the client workstation is configured with a default gateway, which is the self IP of the SSL orchestrator. So all the traffic is gonna go through the SSL orchestrator. But in this case, as I mentioned, the gateway will be the SSL orchestrator. And when we create a layer 3 transparent proxy, of course, the virtual server on the SSL orchestrator, F5 SSL orchestrator, will be the 0000.0 listening on any port for the TCP and UDP traffic. And of course, this virtual server will be configured on the internal VLAN. So when this client is use a web browser and access HTTP or HTTPS, the web application request will be forwarded to the default gateway and answered by the SSL orchestrator transparent proxy, which is the TCP virtual server, of course. The TCP virtual server you can see in this screen. So it will forward the traffic through a service chain and then forward it to the internet. And if the client workstation use a different protocol, non-HTTP one, let's say Skype, any other protocol, even the default gateway being the SSL orchestrator transparent proxy, it will forward the traffic through the service chain and then forward to the remote host. So this traffic, as I mentioned here, this traffic could use a different service chain. However, this traffic could even identify a different classification rule using a service chain. So in some environment, someone asked me, by the way, in the question, someone asked me if the SSL orchestrator needs to be the default gateway. No, we can keep the default gateway. For example, the internet router or any device on the network, but we need to insert a route hop between the gateway router and the internet, which is the SSL orchestrator in that case. Okay, so if we don't want to do any changes on the infrastructure or network infrastructure, we can have a default, we can keep the old default gateway and then add a route hop, which is SSL orchestrator. So when in that case, when we are using the layer 3 transparent proxy, no modification needed to be made on the client workstation or on the network level. So in that case, we require no modification. However, just I need to note as well, or one note to be added here, the SSLO can route traffic flows across multiple networks. So these devices can be in different networks, and the SSLO can have, of course, different VLANs. For the people who knows F5 configuration, we can create multiple VLANs and we can steer the traffic to these devices, even if they are sitting in different subnets or different VLANs on the network. Okay, this is for the layer 3 transparent proxy, which is the outbound proxy. Any question on the outbound proxy, guys? And by the way, you're gonna have hands-on experience on that. Oh, I remember something. All of you, I think, have received an email from F5, or I think it's a no reply email where you need to register on the UDF of F5 and create your own lab, to create your own lab access. Please, you can launch now your lab. There is some instruction. If you can, we can take like 5 minutes. I need from each one of you in the chat or in the question area to confirm that he was able to launch his lab based on the instructions sent to him in his email. Please take 5 minutes to launch your F5 lab machines in the UDF cloud of F5. Okay, thanks Anjas for confirming able to access. Please launch your lab. I will try to demonstrate to launch the lab as well. You can go here. You can go here. You will see all this. You should log in first, okay? Then you can go to, you're gonna see this course session, which is PBC, half-day SSL orchestration course, okay? And you can click launch. Actually, you should log in first. And sign in and see the course, then you click join. Okay. After clicking join, please make sure that you click on this button, which is deployment. If you don't click here, so if you are here in front of this page, it doesn't mean that you have launched the course. To launch the machines and start them all, you need to click on the deployment, and you need to see them all with this sign, the play sign. Okay, otherwise you're not going to be able to log in and access the lab. For documentation later on, for the bootcamp documents, you can click here and download the course step by step for the lab. Okay, Jocelyn, have you registered yourself before, Jocelyn? Yeah, actually, Muhammad Juma, you need to log in as non-F5 employee. So here, for example, you need to log in as non-F5 employee. Jocelyn, if you haven't received the email with lab access, if you have registered yourself previously, please try to check your junk inbox. Your junk. Can't access the guide. Raj, Paul, you cannot access the guide.
Hi, all. Jocelyn, could you drop in your email address, please?
Yes, she already. Raha didn't as well receive the UDF email. You should have received it, Rahad, as well. Check your junk inbox, please. Hamad Jama, you need to log in as non-F5 employee. For the people who already registered, please confirm and take 5 minutes break. Maybe you want to have coffee or water. Please just confirm in the chat. Okay, I got your point, Juma. Okay, Sheikha, I'll send Sheikha.
Yes, yes, Serge.
I'll send you the guide. Please share it with all the attendees. Okay.
Yeah,
I'll
sure.
send you the lab guide. Okay.
Yeah, sure.
Muhammad, I'll share with you. Juma, I'll share with you the lab guide. Okay. Mr. Pratik, thank you for the feedback. Okay. For all the other attendees able to access your UDF. Guys, you all have access now. Alfonso, Ahmed, Anas, Anil, Anna, Jocelyn, Karthik, Madhuri, Mahmoud Adam, Mashood, Mudresh, Rahat, Raj, Tanish. You have all access. Alfonso, have you registered yourself for the bootcamp previously? Mahmoud, thank you for the feedback. Okay, Rahat, let me try to send a guys, you should have received an email from no-reply@registration.udf.f5.com. Okay. Once your account is activated, you can browse the https://udf.f5.com/courses. I'll send it in the chat. Shikha, did you send the guide? Shikha?
Hey, Serge, Ryan back here again. She's sending it right now to all attendees.
She sent it already?
No, she's sending it right now. It's
because
going to
there
be
is
sent in 2 minutes.
a lot of attendees, Ryan, they cannot access their UDF.
Lab. She's sending it right now.
Alfonso is able to join now. Okay. For the people who wants to know how to join the course, I'm sharing a link as well in the chat. How to join the 5 training course, and for the people who want as well to see the training course interface, how to launch, I'm sharing another link in the chat. I'm gonna wait like 5 minutes more to continue with the presentation. Please, guys, I want from all of you to make sure that you have received the emails. You are able to join and to have the lab experience. Please, this is the main purpose of the bootcamp. Be able to configure.
Sorry. Anil is asking that it's asking for a Microsoft SharePoint username and password.
No, the course material will be shared by Shikha. You don't need to click on the SharePoint. Yeah.
Okay.
You can. Okay. I'm gonna share now the links and the for all audience.
Okay, give me Jocelyn.
No, for the guys, for the deployment description, don't click on the SharePoint link. You're gonna receive an email from Shikha with the guided with the lab guide. Okay, just if you can see, guys, my screen. If you can see, guys, my screen, don't click on this one. Don't click on the deployment. Go just click on deployment. To click, when you click on the deployment, the lab will start. Anil, you're not going to be able to log into the F5 SharePoint, okay, directory. And just I've shared the links now again with all the audience on the chat window. I don't know if you'll be able to see. Okay, you are able, Alfonso, you are able to log in, but no course. What do you mean? You cannot see the screen? You cannot see this? Try please to refresh, log out and log in again. Shikha, Ryan, Shikha have sent the email?
Yes, the email has gone.
Okay. Okay, 3 minutes and I'm gonna start again with the presentation. Please guys confirm your ability to access the labs, please. And make sure once you log in, have you registered Alfonso to the course? Have you registered or have you sent received the email? Have you received the emails for the course? Very good. Thank you, Sanish, for the confirmation. Don't start, guys, don't start with the lab now because we need to see how we configure the SSLO and later you can start with it, okay? Alfonso, you have received this you have received the lab email, but you are not able to access. Okay, let me check. Alfonso, yes, try Google Chrome, please.
Yeah, I think, Sajeevan, we had mentioned in the emailer that Google Chrome is the preferred browser to run this on. So I hope everyone's using
Okay,
Google Chrome as well.
Jocelyn, you're gonna receive the, another email from F5. I just want, I will need just your email. I received your email address. Ryan, please, if you can just send an email to Michael with the people that have problem in the access. Okay.
Sure.
And give me in the email. I think Rahat now can access. Rahat, can you access the lab? Okay, please send the email of Alfonso as well to Michael, please, Ryan.
Sure. Sending it right now.
Okay, who else has a problem?
So Jasleen and Alfonso, right?
Yes. Who else, guys, has a problem in accessing the lab? Okay, Rahat has a problem as well. Ryan, please mention the email of Rahat.
Sure, I've taken it down and I'm just sending the list to Michael.
Okay, Rahat. Okay, Alfonso, Alfonso, I got your message. Okay, who else, guys? Okay. It seems that all the others, they can access their lab. Okay. So let's proceed with the with our presentation and the topology. So we have seen first the layer 3 transparent proxy topology. Let's now move to the layer 3 inbound proxy, so which is the next topology, and this is known as well it's known as well as a reverse proxy gateway configuration. And this topology is designed to sit in front of any other ADC, such LTM with an existing virtual server within the same organization data center, or even other type of application delivery controller, or directly web applications hosted using public IP addresses. So in this example, we're gonna check the client that are accessing from outside, the external users that need access to the web applications inside our organization network. So when we create a layer 3 inbound SSL you will end up having a 0000 listening on port 80 or port 443 virtual server. Okay, on the external VLAN of the SSL orchestrator. Someone is asking a question. No, Maduri, you don't need to access this SharePoint. My colleague Shikha have sent you the guide, the the guide to access the F5 lab for the SSL orchestrator. Okay. Brian, if you can just answer Madhuri, please, in the chat or in the question.
Sure,
Okay.
sure. I will reply to it.
So again, when the users are in the layer 3 inbound proxies, when the user make request to the web application public IP address, the requests are routed through the SSL orchestrator inbound proxy virtual server, then through the configure service chain, and then the target will be the web applications, as you can see here. So as with the previous topology as well, the outbound one, the layer 3 inbound proxy with the SSL orchestrator can route the traffic flows across multiple networks. So even if these security devices are in different networks, the SSL orchestrator can steer the traffic to them. Any question on the inbound proxy architecture? Okay. Now the layer 2 outbound proxy. Okay, this is a critical topology. A lot of customers will be asking about that, but it's not recommended in F5. However, we recommend always the layer 3. The benefit of the layer 3 is be able to steer traffic as you want. You can add all type of devices, layer 3 devices, layer 2 devices, ICAP, web proxies, all of them. So with the layer 3, the SSL orchestrated topology and layer 2 outbound proxy. So this topology usually is used when all network and security devices are in line on the same network. Okay, you can see here, you can see that this is the gateway and the SSL intercept the TCP traffic on the route to the router. Okay, and all these security devices with the SSL orchestrator are sitting in the same network. So for example, in this network, all these clients here, you can see that they are in the same subnet, which is 10.1.20.0 network. So when we add the orchestrator to the traffic flow, as I mentioned here, there is no need to route between the layer 3 subnets. So when we add the SSL orchestrator to the traffic flow using the layer 2 outbound topology, we provide a transparent path for outbound traffic. And this prevents no disruption to the traffic because there is no need to route between layer 3 subnets. And when the client submit the request, it's directed to the default gateway, of course, which is in this case 10.1.20.254. And then they will simply go, the request will simply go towards the router, which is the SSLO listens and intercept TCP traffic, and it decrypts the traffic, send the traffic through any configured device chain before the encrypting and send it to the traffic along the egress side to the router, which is 10.1.20.254 and on the internet. As I mentioned, from pre-sales perspective, layer 2 design is always attractive to the customers, okay? Because it does not need to change anything from the customer existing network configuration. But it is also true that the layer 2 design can bring other complexity to the network device. For example, many of the SSL customers probably want to build HA configuration because SSLO does not support inline bypass function fail open. So no pass means we need to ensure that SSLO is always up. But once we configure SSLO with layer 2 HA high availability, we also need to keep in mind to configure the spanning tree protocol to eliminate layer 2 traffic looping issues. This is because, of course, of the STP nature. It also brings the complexity of the network configuration in the existing network. And this is the disadvantage of the layer 2 SSL orchestrator or packet broker in all the environment whenever we are configuring them in the HA. Okay. So this is a major reason why we do not prefer to go with the layer 2 design in the SSL orchestrated configuration. But this is very important point. If the customer doesn't need an HA configuration, the layer 2 design is a good solution over other competitors. So if we really need a fail open solution, we can use any other fail open kit which will need a fail, which will help us in the functioning of the SSL orchestrator when it needs a fail open. So it will need, the SSL orchestrator will need a fail open kit, and of course the connection can go through this fail open code. Of course, if we want redundancy, we do need HA for the SSL orchestrator, but layer 2 will introduce more network configuration. Okay. By the way, other SSLO brands has the same problems like us. It comes to layer when it comes to layer 2 HA, and if customer wants a fail open configuration. Okay, this is something that I need to mention, and this is something that we need to as well send this message to our customer whenever they are requesting the layer 2 outbound proxy or layer 2 configuration, outbound or inbound. So this is something that I need to highlight here. And I've mentioned the two ways how to address this challenge. Okay, either we need to have the HA and configure the STP on the network, or even integrate or add if we are going with standalone SSL orchestrator, we can add a fail open kit with it in order to make the traffic flow whenever there is any problem on the SSL, or in order to avoid any single point of failure. Okay, so this was for the layer 2 outbound proxy. When it comes to layer 2 inbound proxy, it combines the similarities of the layer 2 outbound proxy, where all devices are in line at the same network, of course, and the request will come from the user sitting outside, will send the request to any of the applications that are being published. So in that case, the clients need to access the internal web application, where the external users make the request for the web application, and the SSLO listen to the TCP traffic and intercept it. As we can see in this animation, we can see decrypt the traffic, send the traffic through any configured service chain before it re-encrypts it, before re-encrypting it, and send this traffic along to the target web application. Okay, this is for the inbound proxy. For the existing application, this is another topology. This is a very interesting one. Okay, just I received an email from, okay, so Alfonso, you should be able to see now, or able to access now. Jocelyn as well. And who else?
Rahat.
And Rahat. Okay, guys, please try to access the lab now. You should have received the email from F5. For the existing application topology, this is a very interesting one. So it is our last topology. So similar to the inbound topology, this topology is designed to work with the LTM virtual server hosting web applications using a pool of web server inside the data center. Okay, but these are the virtual server on the same big IP as the SSLO. As I mentioned, SSLO can be a license sitting on the same LTM. Is there any question here? Okay, Rahat. Yes.
No,
Okay.
not as of yet. No question.
Okay. No. Okay. So, so with this topology, the SSLO license will be as well provisioned on the same LTM unit. So, just 1 second. Sorry, guys, I need to answer to the F5 team. Okay. So, so as I mentioned in this topology, it's designed to work with the LTM virtual server, hosting web application using a pool of web server inside the data center. But these are a virtual server on the same big IP as the SSL orchestrator. And the virtual server are already performing SSL handling and SSL server traffic management. So okay, so at the layer 2 and layer 3 inbound topology provide an inbound gateway function for the SSLO. This topology works with virtual server that already perform their own SSL handling and client server traffic management. So you can notice here the HTTPS. You can notice that these virtual server are publishing some of the application. And what will add, the SSLO will add some steering as well before being sent, some traffic steering to the other services or other security devices before sending it to the web application. So this external user already have access to the web application using the virtual server without the SSLO. However, by using the SSLO existing application topology, we can take advantage of service chains. We can also take advantage of other SSLO features like security policies and analytics. Okay. So now we're gonna go for the guided configuration. And before going to the guided configuration, I need to know if anyone has any problem in accessing the labs so far. Ryan?
So far, no questions. Yeah, we got one from Jocelyn. Password to log in to the lab will be received on a separate email.
You need to create your own
Password. Sorry, your voice cut off, Serge.
You need, can you hear me?
Yeah, yeah.
You need to create your own password when
But
you
it won't come on a separate email, right?
No.
Okay, that's about it. There's no more questions.
Okay. Forgot password is not working. Jocelyn. Have you received your first email, Jocelyn? Okay, Jocelyn, I'll call you later after this chapter whenever we're going to start with the hands-on, okay? Okay, let's proceed with the last lesson, which is the SSLO guided configuration, okay? And we're going to see how it's easy to configure the SSLO configuration. So as you can see, we're going to now walk through all the steps of the SSLO guided configuration. and we can start by accessing the SSLO orchestrator tab, and under the SSLO orchestrator tab, we can just click on the configuration page. And this page simply displays the steps involved in creating the SSLO configuration. But you can notice here that you can go right and left with the topology that you want to choose. So here you can see the layer 3 outbound transparent proxy, there is a layer 2, and so on. Okay, so you can notice here the steps that we're gonna go through while configuring. So we're gonna choose the topology, the SSL configuration, the services, the service chain, the security policy, the interception rules, the egress settings, and the lock settings. Okay, so you can notice it's very straightforward to configure the SSL orchestrator. So the first page is the topology page. So first we need to enter the name of the name of the topology. Let's say we can call it transparent proxy here, and we need to choose the protocols. There are 4 protocols. Each protocol will enable us to use a specific topology. So the TCP enables us to use the layer 3 transparent proxy, explicit proxy, inbound proxy, and the existing application topology. However, the UDP enables us to use the layer 3 transparent proxy, as well the inbound proxy and existing application and existing applications. Okay, but not the of course explicit proxy. Other protocol enables us to use the layer 3 transparent proxy, inbound proxy, and existing application topologies. Okay, and any enables us to use the layer 3 transparent proxy, explicit proxy, and existing application topology. Okay. So as I mentioned, these are the topologies that we can use. And finally, on this page, you can select from the 6 topology that we covered earlier. Okay, that the layer 2 outbound, layer 3 outbound, explicit, layer 2 inbound, layer 3 inbound, and existing application. Then we click save and next. So in that example, we will choose the layer 3 outbound, and you're gonna do the same during your lab. Then we click save and next. The next page is the SSL configuration, okay, page where we define the specific SSL settings for this selected topology. So the CA certificate key chain, we need to add, of course, the local CA certificate and key that the SSLO will resign or forge. The SSLO will resign or forge a remote server certificate to local clients. And here we need to know that the internal clients must trust the configuration, the configured local CA. So we can put the local CA as well here. Okay, CA certificate key and chain. And then we need to do the server side part. So the server side SSL setting most likely don't need to be modified, as a big IP system includes a CA certificate bundle that maintains a list of CA certificates common to all the browser's vendor. Okay. Then after that, we need to start listing our services. And if you remember, the services are referred to our security devices. So, and we can have different device types. So we need first to click add service, and we're gonna be presented with different services types and we can select from where we can select from. So each option specifies the service type, HTTP web proxies, ICAPs, devices, inline layer 2, inline layer 3, tab devices, and from different brands, by the way, you can see, but it's not limited to only these brands, because you can see that in this service catalog, also we can provide the generic service, security service for each of the service types. You can see the generic HTTP service, generic ICAP service, generic inline layer 2, generic inline layer 3, and generic tab. So if the specific products or vendor is not listed here, you can just choose from the generic list of servers. So to configure a service, we need to double click on it. So let's say here we choose the FireEye and X inline layer 2, we double click on it, and we need to start to configure this service. So we need to note as well here, it's very important that for each service we have service settings, so each option differ depending on which service we have selected. So first, for example, for this service, we need to give the service name. It's important to note that the SSL OS will be prepended to the name of the configuration. So we create here FireEye _ device. We need to add the, of course, the network configuration. So we add, so we must define both the from big IP and the to big IP VLANs. So we can create new VLANs, or we can use from existing VLANs, but in this scenario, we're gonna create new VLANs for the from big IP VLANs. We can give the VLAN name. So here, let's say we can put FireEye VLAN in, and this we can specify the big IP interface, of course, as well, which is gonna be connected to this FireEye in interface. We can specify the tag. So this VLAN taking traffic to the inline service device, and we need as well to configure the VLAN that is from where the traffic is going to be coming from the FireEye device to the F5 SSL orchestrator. So we can create the VLAN FireEye VLAN _ out, and the interface from where the FireEye is going to be sending back its traffic, which is 1.6 here. So this is the VLAN receiving traffic from the inline service device, and then we click done. Okay. So, and if necessary, we can select enable port remap. This is very important to know, because usually, okay, enable port remap, usually this traffic is encrypted, right? So it's using SSL. So usually it will be configured with the default port of the SSL traffic, which is 443. But if we don't want to use the 443 traffic, and if a service by default ignores port 443 natively, we can remap HTTPS traffic on the security service to be inspected on a different port. Okay, so this ensures that the security service will inspect traffic it natively would have ignored. Okay, so we can save, and then we can add. We will have a complete service created, and we can add additional service such as this the IPS, the tab device, the HTTP proxy, a DLP, and so on. Okay, once we add all the device, the next step is creating the service chain. As a reminder, just for you to know, guys, a service chain is an ordered list of security device. So to create a service chain, we click add, we can give it a name, and we can see all the services, which are the security devices that we have created previously in the available list, and we can pick this the available from the available list to add to the service chain. And of course, we can specify the order. We can change the order in which the services will start to inspect the traffic. So we now have complete service chain, and of course we can add additional service chain, each containing a specific number of devices in a specific order. So we have created the all services, the fire ITAP device, the IPS only, and so on. After that, we need to create the security policy. So on the security policy page, we set the rules to determine how traffic is processed through the SSLO. So we need first to classify the traffic. So once the traffic is classified, there are 3 actions we can add to a rule. Okay. This is how we classify the traffic. Okay, SSL check, for example, for the financial bypass. Okay, how we configure the security policy. Okay, we can allow, reject, and decrypt the traffic. So for example, here, before creating this policy, you can see that we have action allow, we can have the reject and the decrypt. Okay, so let's start first with the configuring the first. And by default, you will see that we have 2 different security rules. One which is the pinner rules, and one which is all traffic rules. For the pinner rules, just the pinner rules applies a search of a built-in custom category, and via some incoming SNIs populated with URLs of known pinners. A certificate pinner is specifically for a user agent that can detect if TLS has been broken between itself and the target server. A certificate pinner has a predefined information about the target server, usually by way of hard coding servers or issuer certificate information, and so on. Let's not focus a lot on the pinner rules. We can delete it. Most important thing is to take away from the certificate pinning is a function of the user agent. Okay. So to add a new rule, we click add. Okay, first we give a name for the rule. We are going to create a rule for bypass decrypting for a financial bypass. Okay, usually it's going for the financial URL category. So when we then we then specify the classification by defining 1 or more conditions. So first we put, for example, SSL check true, plus we add another condition. And this condition, we are checking the URLs, destination URL category, look up all, financial data service, health and medicine, and so on. Then we specify that it should be matching all. Okay, so it's not match any, match all. Okay. So this is the full classification for this rule. Okay, then we can select if the action should be allow or reject the request. Of course, it should be allow, but the action allow, we need to select the bypass since we don't want to decrypt or intercept the request. And we can specify which service chain is gonna be in this security policy. Obviously, it's gonna be the IPS only. We specify the IPS only, and we can now see that the rule is completed. We can also edit rules by clicking on the pencil. For example, we've edited the default rule. Why? We want the service chain for this rule to be all services. And then after configuring the service policy, we need to do the interception rule. In the interception rule, in this page, we define the listeners to accept and process traffic types of the traffic. So this is from the egress part. So the interception rule will be based on the topology selected, of course. And this page defines the listeners. For example, the virtual server which accept and process different types of TCP, UDP, or other traffic. Okay, so we put the source destination. In that case, it's any source and any destination. It should go to the egress network, and we can specify that it should be from the client VLAN because it's coming from the client side, it's outbound. This is the VLAN that the traffic will be entering the SSL orchestrator. Okay, then we can select any server speak first protocol that will be processed. Let's say if you are processing FTP or email protocol traffic, which are server speak first protocol, you must specify the correct protocol in the selected list. Then we can as well ingress and egress setting. We can put the egress setting of the SSL orchestrator. So the egress, we need to specify how the traffic will be processed from the egress interface of the SSL orchestrator. So and we need to define as well the SNAT settings. I'm sure that you are familiar with the SNAT settings of the LTM. I will not explain about that. And the gateway settings, of course. So for example, we can select here the SNAT list, or we can select the SNAT automap or an existing SNAT pool as well. Then we can, in that case, we have used the automap, and then we can use as well the gateway list to add gateways and select, for example, here the default gateway route, which was created, which is 10.1.20.1, which is the gateway of the SSL orchestrator. And then we can create the log settings page. And this log setting page, we can change the default log level of different SSLO facilities. So for each SSLO facility, there are several log levels, which you can view in the right side of this page. You can see that we can have emergency, alert, critical, error, warning, notice, information, all these. It can emergencies. You can see each one of these alerts defines what will be logged in the event logs. Once configured, we can have configured everything. We're gonna be in front of a summary page. We can open all the sections. You can see here topology. You can click on it to review the configuration. And after viewing a section, we can also click on the pencil icon of one of the section if we want to modify anything. And it will return us, of course, to the section where we can edit settings. So here, of course, once we are completed and ready to, we can click deploy. Obviously, after clicking deploy, we hope that we get a successful deployment if there is any problem, it's going to be highlighted for you in the configuration where you need to go and fix it. Once this SSLO deployment is completed, we can view information about the configuration of the button at the bottom of the page. You can see here, we can view individual items such as interception rules, which are the listeners of virtual server that were created, or security policies. For example, you can see the security policies that are created. Here you can see the transparent proxy and so on. As well, we can see the dashboard here of the SSL orchestrator to view the statistics chart format in various categories, such as percentage of the decrypted and non-decrypted traffic by the SSL orchestrator, the top 10 URL categories, the cyber version name, of course, the throughput average, the memory usage, the CPU usage, the overall status. And you can mouse over the dashboard area to view more details about the top 10, for example, here, alerts, or even here you can mouse over to see, for example, the plain text traffic and the percentage of it, and so on. With that, we reach the end of the SSL orchestrator theory part, or the presentation part. And now I'm welcoming everyone to have his hands-on lab, to go and start with his hands-on lab. Please feel free to ask me any question on your hands-on lab experience if you are facing any problem. I assume that now everyone has his username and password and his credentials. I mean, his credentials and his profile, where he can access and launch his the SSLO lab and start to configuring. In this guided configuration lab, you're gonna test the outbound access for an internal user, add SSL orchestrator configuration, give internal user outbound transparent proxy access, add a custom security policy to the SSL configuration, and its estimation of completion of this lab is 60 minutes. Please feel free to ping me if you need anything. And if you want, guys, we can all join a team session. A team session, if you want, to access, to help you in a remote access if it's not doable from here. Please, first of all, confirm that all of you have access to his lab, and whoever wants me to help him in anything on the lab, please send me a ping and or ping me. I can enter with you with a team session to help you in the lab if you are facing any difficulty.
Serge, I think Anil Gupta from JBM, he isn't able to get the login as of yet. Should I send an email to Michael? He's not able to access the log. He's not able to access the lab. Anil for GBM.
Anil, he's not able to access the lab. Okay, who else can access the lab?
Is there anyone else? If you all can put it down in the Q&A section if you are not able to access the lab. No more. I'll just send Anil's request across.
Guys, please feel free to ask me any question while doing the lab. We are here to support you. I don't know if my colleague Kauk is here. Okay, he's not. Okay, I'll check for you, Jocelyn. Just give me a few minutes. I'll contact my colleague, Michael. In the meantime, Jocelyn, if you want, I can, if you can share with me, not go to meeting, sorry, Teams session, I can log in with you and check what's the problem exactly. Guys, we're gonna add you on a Teams session now. In that Teams session, you'll be able to share your screen. Okay, my colleague Ryan will add you on this session. Ryan?
Yeah, sir, just sending it across. So everyone will receive a Teams meeting, so they can all join in.
Okay, guys,
Then
please,
it'll be more
Teams
interactive.
meeting, okay? To make sure that the session is more interactive, please. Ryan, once you send the email, please share with me
That you would have received it.
share in the chat here or in the Q&A section.
Yeah.
Teams
Join
the
me
link as well. Yeah.
Sure.
I'm joining the MS Teams meeting, guys.
Sorry. If anyone on the GoToWebinar cannot join in, please drop in a question so I can send you the link for the Teams meeting.